Hello everyone and welcome to this new course entitled Graphs, Theory, Application, Algorithms and Implementation. So the code of this course is I2205. So today we'll start with an overview of C++. So why we are using C++, especially for graphs. So we've already covered last year in the course I1101 the foundation of C. So however, while we are treating graphs, we need more structures. So we need to deal with stacks, queues, decks and priority queues. So for that we will be using C++ since there are predefined and already written libraries in order to deal with that. So we'll cover today dynamic vectors and then some sorting and searching functions that are already built in and implemented in C++. Then we will cover some how do we use stacks, queues, decks and a priority queue. So this is the outline of what we will learn today. So in order to write a program in C++, so it's the same as in C because C is embedded in C++. So whenever you are writing C++, you can use the same syntax and the same concept as we have covered in C. Just to know that in C++ we can have, so it's an object-oriented programming, so we can have objects and some functions that are embedded in those objects, but we will not cover those topics. We will be dealing in C++ as if we are programming in C. So we have to import or to include some libraries, and then we need to write the main functions or any more functions. So the same as in C or in C++. So I have this main function, so I can, for example, declare an array. So it doesn't change anything. So let's say a of 10. So it's totally normal. So and as we have seen earlier last year, that we include the standard input output header file in order to do a printf and scanf, so to read and write to the screen. So if I want to the equivalent of this library in C++, so it's called C standard input output. So we can use scanf and printf. So in C++ we have also other functions to do the scanning or the printing on the screen. They are called say in, say out, so character in, character out, and they are included in the IOStream library. So I can include also IOStream in order to use the functions of C++ concerning the input and output. So we will be using also other stuff. So in order to use the function here, they are embedded into a namespace called standard, so std. So instead, for example, let's have a variable here, and in a I will put 5, and then I can use printf. So this is totally normal. So a, so printf. So I will build and then debug my solution. So there's succeeded, there's no errors. And then I have seen a 5 on the screen, so I will put a \n. So the equivalent of printf is the function called cout, and cout, it takes two small less than a character, and then I can display the value of a. So let me add an AND line, so I can use also the special character \n in order to print that. So whenever I write cout, it tells me that it's undefined. Why? Because it's part of what's called a standard. So I need to write std cout. So we will see later how do we overcome this. So let me build this and then do a debug. So at the end, okay, I have got the same output twice. So 5 and 5 because I'm using standard the output. The standard library with cout. So instead of writing always this stuff, so I can remove it and I will declare that I will use the namespace using namespace what we called it the std. So later on, whenever it sees a cout, it will be understood that it's part of the standard library. So let's do a build. So obviously I will not have an error, and then I will do debugging and I will end up with the same output. So we have seen, so in order to use printf, I have included the standard input output. In order to use cout, I have used the input output stream. So you can use any of these since we are using C and C++ at the same time. However, you should know that if you want to do a sophisticated output, you cannot do it easily with cout, so it's better to use printf. So the same applies for scanf and cin. So in order to do a scanf, so let's do it here. So scanf %d, so we know that address of A, and then I can print its content. Or if I'm not using scanf, I can use cin. So the input is greater, so it's the opposite of the cout, and I just need to place A. So it means that I read a value and place it in A. So let's try it. So I will do debug without debugging. So obviously I need to enter a value. So here's two value. So let's say 3 and 4, and the output will be 4 because I have overwritten the value of A. So obviously, since I'm using this std namespace, there is no need to place here std with two colon. So this is the idea. So we'll move now to arrays and vectors. So let me remove all this. So we know that we can declare an array like this in C. So it means that I have reserved 10 elements of type integer. So I can do a for loop in order to fill all these elements, or I can, for example, initialize these values. So I will not use 10 because I need to enter more values. So let's say 5, and I will add, for example, 4, 4, 4, and that's it. So we know that I have 5 places, 5 cells. However, I have filled 4 places. So we have learned that the fifth element would be equal to 0. So this is static. It means that the array, it will always contain 5 elements, and if I want to add more elements, it will be impossible. However, in C++, we have what we call a dynamic vector, in the sense that we can add, remove, or shrink the vector. So in order to use vectors, I need to include the library, which is called a vector. So vector, it's like an array, but it's dynamic. So we'll see what does it mean dynamic. So in order to declare a vector, so it's a type, and I can declare, for example, v. So we'll see here that we need to add some other stuff, and it could have some initial value and a number of elements. So like this, it means an error. So it tells me argument list for class is missing. So I need to tell him what type of vector. Is it a vector of integer, a vector of float, double, or strings? So this is why we need to define the type of this vector. So we use this notation in order to say that v is a vector of integer. So this is just a vector, but we didn't define its size nor the initial values. So if I want to do the same like this, I need to use a bracket. The first parameter is to say that I have 5 elements, and the second one is, for example, the initial value. So it's said here. So it's a vector, which is some constant allocators and stuff. So we don't need to know all this stuff. So this is mean that in my array, I have the values 4, 4, 4, 4, and 0. And in this one, I have five values, and all are equal to 5. So this is a very convenient way if I want to initialize an array to a specific value. And if I don't want to do that, so for example, I can declare just a v of 5 to just say that I want 5 values for now, but I can modify its value, and then I can assign a specific value. So I can do v dot assign, for example. So the assign, it takes a vector, and we can assign some value. So for example, I can say assign 5, 5. So I need to remove this from here to say that I have v would contain 5 values, and each of these values is equal to 5. So this is a very convenient way whenever we want to create a dynamic vector and to initialize it directly. For example, if I want to initialize it to 0 or -1, all the values. So this is a very convenient way to do that. So let me keep it here and try to do some output. So I will use first a for loop. So let's do it for loop. So for int I equal to 0, I less than 5, I plus plus. So here is a 0, and then I can print f. So I will use the C notation here, and the percentage d. So let's make it more convenient. A of percentage d equal percentage d backslash n, and the first one is the counter I, and the second one is the value of a of I. So this is totally normal, because this is the normal array that we have covered. So we can do the same for the vector. So I will join them all together. So why not? So I can say here v percentage d equal percentage d. So I can iterate over a dynamic vector the same way as I have done for normal arrays. So we'll see for 5, for 5, for 5. So we have a failed. So because it's a capital V. So let's debug again. So we will not see the screen because I didn't do without debugging. So we see that we have 4, 5, 5, 5. So as we have seen here, I have the A vector is equal to those values, and the V value are equal to those. So we can modify or access the element of a vector the same way as we have done for an array. So let's move forward. So let's suppose now I will remove this, or I will keep it as a command. Maybe we'll use it later. So, and let's suppose now I need to add in the fifth element here the value of 5. So we have knew that whenever I'm declaring an array of 5 elements, obviously we cannot access the fifth element because it will be out of bound. So if I will build, so there's no error because this is not a compilation error, it's a runtime error. So whenever I run the program, I will have an issue. So obviously there's something wrong, there's a runtime error because I have tried to modify an out-of-bound element. So this is not the case whenever we are dealing with vectors, because vectors are dynamic. So I can easily place here v of 5 equal to 5, and then there's nothing wrong, everything will be fine because it will dynamically grow up and it will accommodate the newest value. So obviously here expansion vector, it's out of range. So this is not the way we do that. So in order to overcome this in using vector, so I can add an element at the end of this vector. So I will use the function push back. It means that I will push it the back of the array. So here 5, and then so I will reuse that. So this is the purpose, and I will just print the value of the array. So now, as you can see, even if I have declared the initialized the vector v with 5 values, I have ended with 6 values. Why? Because it's dynamic and it can grow up whenever we want to add new elements. So we don't have the same problem whenever we are dealing with static arrays. So this is why we will not use static arrays. So we have seen that this capability, so we can add elements, so we can also loop over a vector. So just to know that in vectors we can use iterator. So it means that I can loop differently, not using the integer I or I++. So let me just show you how we can do that. So we'll use a variable called auto. So auto, it means an integer, so it will be an iterator. So our iterator, so it means it will loop over an array. It will start from v.begin. So begin are functions which we call iterator. It will reach till v.end. So also it's an iterator. So it means that it will loop until the end of the array. And obviously I need I++. So in order to print the content of that, so here I will use cout and I will use dereference I. So dereference I to say that it's the element pointed by the iterator. So let me just debug to see the output. So yes, I have 5, 5, 5, 6 times. So because you have 5 times 5 plus 1 times 5, so equal to 5. So let me repeat that. So we have an iterator called v.begin. So it's the vector v, and begin it's the function. So in this function, it means it will return a pointer over the first element of the factor, and v.and it will return a pointer over the last element of the factor. And we use the rotation, the dereference I on the iterator in order to display the content of this array. So let me just change a bit here, and let's place here 6, and I will redo also the output just to see that the last element here is equal to 6 in the output. Okay, so I can loop from the first to the end, or also I can loop from the end to the first. So I can also do that, and it's very easy using vectors, so there's no need to say I equals size minus 1 and stuff like that. I can just use an iterator that starts from the end of the array and it will reaches the start of the array. So it's very convenient. So here, so maybe it will not work because the pointer, maybe it's less than the r begin, so I can use the different one, the different notation to say that I is different as long as it's different from a rand. So let us check this if it will work. So it will display from 6 to 5. So yes, it will display from 6 to 5. So it's a very convenient way also to loop from the end to the beginning of the array whenever you need, for example, to do some reverse or stuff like that. This is a very convenient way. So we have some predefined functions for vectors, so to know the size, the capacity, and the maximum size. So we'll see that. So in order to display, let's say, the size, so we have v.size. We have also the capacity and the maximum size. So I will print out all this, and then we will see the output, the difference between size, capacity, and maximum size. So obviously size is the actual size, the capacity how much it can accommodate. So maybe we have removed some elements from the array, from the vector, so the capacity will remain the same, but the size will be shrinking. The maximum size is the maximum size that can accommodate this vector, so it's limited by the compiler and your PC, so it's called max size. So let's run and see the output here. So this size, so we had to place some spaces, let's say equal, it will be more convenient. So but I will not redebug it. Also we have here a lot of stuff. So this size is equal to 6, obviously, because we have 6 elements. We have the capacity is equal to 7, because whenever it was equal to 5, we have added an element, so the compiler may increase the capacity, and the maximum size is the maximum that can accommodate. So if you want to see how can we play with the size, so obviously I need to remove an element from this, so I can remove one, I can shrink it. So we will keep that just for a bit. So I can, before doing that, I can do a resize. Resize, it means I can shrink the size of this array. So let's say since the size of this array is equal to 6, I can resize it, for example, to 4. It means that I have lost the last two values. So if I do debugging one more time, I will end up with size here equal to 4, because I have resized it to 4 elements. So the capacity will remain the same because it's already reserved in the memory, and the maximum size is the maximum size. So this is the difference between the sizes whenever we are dealing with the vector. So here again we are showing that the vector are dynamic, they can grow, they can be shrink as we add and remove elements. So we can check if an array is empty or not. So we have the function so we can use the function size or empty. So if it's empty, we know that. So in C++ we have the constant, the Boolean constant false and true in small letter, not like in Python. So I can say here that it's empty, and otherwise I would say it's not empty. So in C++ we have also the end line end of character. So it means that whenever we have \n, we can use endl. So let's do it without debugging. So we have here the size, and it's equal to 4, so it's empty. so it's equal to false. So here it's not empty because if it's equal to false, it means not empty, and if it's true, it will be empty. So this is the one of the functions. So in order to also we can so we have seen how to reference an element. So let's, for example, print here. Let me remove this. I will command these, and I will keep the 6 elements in the array in the vector. So I can use printf, or I can do cout. Let's do cout, and I can display the value of v2, for example. So here's the end line, so you can use the end line, so it's the \n equivalent in C++. So I have here 5. So let me remove the output so that to see that the value of v2. So I can write here v2 equal v2 which is equal to 5. So it's now on the screen. So I can also so instead of using the notation, the bracket notation, I can use the function at. So instead of these, I can use v.at and the position 2. So it's the same as v of 2. So let us, for example, pick the value of so let's say v of 2. It's okay. So also we can get the first value of the array. So it's called v.front. So for example, v of 0 is the same as v.front. So let us initialize those. So I have v of 5, and I can add, for example, 0, 1, 2, 3, 4, and then I will add 6. So I will have a different output here, just not to have the 5. So I have failed. So because I have equality here and I have 5, so obviously I should not use the number of elements. So I have 2, 2, 0, so the second element 2, and the first one is equal to 0. So we have the function front. So if I want to get the last element, it's called back. So v of 5 is called back, v.back. So it will be equal to 6. So it will be equal to 6. So whenever I have an iterator like this, so I can get the current value pointed by the iterator using the function data. So I can declare int pose position, so it should be a pointer because the iterator, it returns a pointer over a value. So v.data, it means the pointer pointed by the iterator. So since we don't have an iterator here, it should be the first element. So if I'm printing here the dereference of pose, so let me do that. So it will be equal to v0 equal to 0. So I can print dereference pose to say that it's the element pointed by the first element pointed by the iterator. So since we didn't loop over the iterator, it will point to the first element. So in order also to print the last element, I can access the last element. So I know that I can get the size of the vector, and I just need to do -1 since the size it will be equal to the number of elements. So and the last element would be of index size -1. So again, let's do a check. Is it equal to 6? So also it's equal to 6. So you have a lot of possibilities in order to deal with those. So we have seen that we can add an element to the end of the array. We can also remove an element from the beginning or from the end. So we'll see how to do all that. So I have pushed back. It means I have pushed an element at the end of the vector. I can also remove an element from the end of the vector. So let me remove all these and also these, and I will keep the output of the vector. So I will display it from the first till the end, and I will remove the last element. So how can I do that? So I have pushed back an element. Now I can pop back the element. So I can remove the last element of the array. So if I do now a printing again, so let me add a cout. So we need a cout and line, and let's see the output. So we have 0, 1, 2, 3, 4, 5, 6, since we have added 6, and then we have removed 6 from by using pop back in order to remove this. So we have this is a nice idea, since in a static array we cannot do that. We cannot remove an element. So the number of elements they are it's constant, and we cannot do that. The trick here also in vectors is that I can add an element in the middle of the vector, and I can remove any element from the vector. So let's see how can we do that. So I will not remove the last element. So let's say I will remove what do we want, for example. So the function is called erase. So let's see it first. So I can erase the first element or any other element. So let's see how we can do that. So we can use v.begin. So we know that this is the first element, and the output. So yes, we have removed the first element. So I can insert, for example, an element at the beginning of the array. So instead of erase, I have insert. So v.begin, and I can place any value. So let's say -5, and let's redebug and see the output. So it should start from -5 now after the output. So yes, I have reached to place -5. So I can also modify the element. So we know that how can we do this. I can insert an element at the end. So we have seen that I can use pushback. I have other function which is called inplace back. We have inplace and inplace back. Inplace, it's at the beginning of the vector, and inplace back is at the end of the vector. So you can try to work with that and see the different functions. So we will not be using all these, just the major ones. So we have added -5 at the end of the array. So in order to clear an array, so I will erase the vector. I can use a clear function. So it will erase everything. So now if I want to print, it will be empty. So I will see just one row on the screen. It's the output that comes before the clearing of the vector. So there is no vector anymore. So we can clear the memory. So there is no more. It doesn't take any places in the memory. So this is the first part where we have dealt with the vectors. So we will see how we can use the algorithm functions where we can sort and do search of elements in an array. So obviously the binary search, and whenever we do sorting in order to do the binary search. So let me erase all these. So I will keep the iterator because I will use it, and I will use also an array in order to see how we can sort and do different stuff using vectors. So let's suppose I have an array. So I will not use the size since I will use a predefined value. So let's suppose I have the values as 10, 7, to 15 and 4. So even if I have an array, I can initialize a vector using the values of this array. So it's easy. I will pass the array and its size. So array plus 5, unless I know the size. So here I have array. So I will rename it as array. So in order to do sorting, obviously I will not write my own function. So I'll be using C++ function. This is the idea here. So in order to use the sorting algorithms in C++, I need to use the library algorithm. It contains the sorting and the searching functions. So in order to sort a vector v, I just need to call the function sort. So sort, it takes 2 to 3 parameters. So it depends. So it will take the vector start and the vector end. So I can pass v, the start of the vector, dot begin, We knew that, and v dot n, so I can pass less than the vector, so I can sort half of the vector, for example. So I'm sorting the array, and then I will print the vector. So we have v, it's all right. So let's see if it will work. So even just by calling a function sort, it will do all this stuff. So I have, yes, it's sorted 2, 4, 7, 10, and 15, easy as that. So if I want to sort the array in reverse order, so here again, what I can do that is I will just use the rbegin and rn. So it's very easy to do that. So rbegin, so I'm not able to write rbegin and rend. Let's debug it again. So is it sorted in the reverse order? Yes, it's sorted in a reverse order. So it's very convenient way whenever we want to sort an array is to use that. So I can use also a partial sorting. It means I need to sort just a part of the array. So in order to do that, I will use the function partial sort. So it's not a full sort, it's just a partial underscore sort. So it takes the beginning, and obviously if I want to do a partial sort, obviously I will not use all the array. So I will do, for example, the first 3 elements. So v begin plus 2. So usually the last iterator is not included, so I will do the sorting of 0, 1. So let's make it a 3, and obviously till the end. So obviously I will do the sorting on both parts. So let's see what we'll have. So obviously, look well, I have sorted the first 3 elements. So it's sorted. However, the last 2 elements are not sorted. So I have the first 3 elements. So I have as if I have the array sorted. However, the first 3 are sorted. However, I will not touch the last 2 elements. So whenever we don't know what's the type of partial sort that is performed in C++, so this is why we can get the last element sorted, or we cannot get it sorted. So we can do some shuffling, we can do some other stuff. It's always possible. So also, let me go back. So I have called the function sort on an array. So I will show you a trick. So I can also call it directly on an array, not just a vector. So also it will work. So it will work on static arrays. So here I have sorted the array, but I have displayed v. So if I will display the array, it will be the same. So let me do for int I equal to 0, I less than 5, I plus plus, and I will print cout array of I. So obviously I will end up with a sorted array. So we have 2, 4, 7, 10, 15 from the first array, and the second one is v because it's not sorted. So we can apply the sorting function on the normal arrays too. However, if I want to sort the array in reverse order, it will be there's a trick also. So in order to do that, so first I will sort the array and then I will reverse it. So how can I reverse that? I just need to call a function called reverse. It will reverse an array. So again, it will take an array and the size of the array. So we say array plus 5, it means that the starting, so we will see later in the I2204 course that an array is a pointer, and pointer plus 5, it means the 5 first elements. So let's see here the bug. So we'll see that the array will be sorted in descending order. So yes, the array is sorted in descending order. So we have seen that the function sort, so it could be applied to both arrays and factors, and we can sort either increasingly or descendingly, depends on the question. So then, so we can also sort on a more complex value. So whenever we are dealing with graphs, so obviously we're not just dealing with arrays, so it would be arrays plus some other values and some strings and stuff. So we'll have a more complicated types, not just integers of float. So what we'll be dealing with is structures, so where we can have multiple elements at the same time. So I'll just use a struct called point. So whenever we say a point, it means it has two coordinates, int x and y. So we have two integers. So we have now a new type called struct point or point. Yeah, it contains two integers. So we have as if we have a higher type that contains many more primitive types. So this is a new type here. Okay, so as if I'm declaring int, it contains two stuff. Now I can use, for example, an array of points. So let's say I have an array of points. So I have point, and I will call it, for example, SP for set of point, and I can declare it as an array of points, and each point contains x and y. So I can declare multiple points. So let's say 1, 2, 4, 4. So we'll cover these also in I2204, where we talk about structures later on in the course. So we have here 4 points. So in order to print or to loop over these points, so obviously this is an array, so I should use the notation since it contains 4 elements. So this is the first array, and each struct contains x and y. So if I want to loop over SP, so I will loop just normally, just to show you how we can access these value. So I will use printf. So let's say point abscissa. So abs point x is equal to %d, y equal %d \n. The first one, so it's called sp of I dot x, and the second one sp dot I dot y. So I'll just show it on the screen to let you know how we can access the member fields of a struct. So we use, so SPI is the array, so it's the first element, second element, and so on. And in order to access the internal element of each point, I need to use the dot notation. So dot x, it means the value in x, and then the value of y. So the first we have 1, 2, then 4, 4, 2, 1, and 3, 3. So this is the struct of points. So the idea that we will be using in the graph is that I need to sort these values. So sometimes I need to sort based on the first parameter, and sometimes I need to sort based on the second parameter. So I have SP, so I know that I can sort that even if it's an array, so I will consider it as a vector, and I have here 4 elements. And then I will print this vector, so SP, and that's it. SP, not S. So I cannot use that because SP is not a vector. So in order to do that, I just need to reprint the values. So I will recopy that, and I will say here cout after sorting. So let's see if the elements will be, the points will be sorted accordingly. So, and also we have a fail. So it's obviously we have a fail because we cannot apply the sorting algorithm like this on multiple values. So it's not just an array, it's an array of a complex stuff, and it will not know how to deal with stuff like that. So in order to overcome this, so the sorting function, it needs to know how it could do that. So this is why we need to supplement this with this function with a predefined function, which we will call it comparison. So we will tell the function sort how we will do the comparison. So this is a function. So this is why we need to write another function. So how we will do that? So we will call it CMP. So the CMP will return a boolean to say how the how the points will be compared. So obviously we need 2 points in order to compare them, and we will say that if the values of y are equal, I need to check the value of x. So I need to compare the value of y or x. So I will write first the first one. So here we are comparing, we are doing the comparison based on the second parameter. So if a of y is equal to b of y, if the second parameter are equal, I need to check the value of x. So I will return a dot x is greater than b dot x. Otherwise, it means that a of y is greater or not greater than b of y. So we need to check y. I will return b dot y is greater than a dot y. So just a comparison between the abscissa and the ordinates of 2 points. I will just relaunch this and see the output. So as you can see now, the output, the points are sorted according to the value of y. So how we have done that? So we know that the sorting, how it is performed. So we do a comparison between 2 points. So how we have done this? So if the value of y are equal, I will look on the value of x in order to sort them. And if there's two values, I will pick. So I will say that b dot y is greater than a dot y. So I will pick the a first, the smallest one, and then I will pick the second one. So in order to see that, I will have the same values of y and different values of x. So for example, I have here, I will place here 3 and I will place 2. So they will be sorted first on the value of y and then on the value of x. So first they will be sorted on the value of y and then on the value of x. So here, as you can see, it's sorted in descending order. If I want to do it on ascending order, I just need to swap the values here. So the values are still sorted based on y, and then I will sort them based on x. So 1, 2, 3, 4, because I have 2, 2, and 1 is less than 2. This is how we have done it based on the second parameter. If I want to do it on the first, so I can also play around. So I will say that if both are equal, and now I will look over the value of y, and otherwise I will check the value of x. So you can play around and see what will be. So here again, I have sorted based on x and then sorted based on y. So let me now change the value of y in order to have it not consequently. So let's say here 1, and let's say we have here 4, and let's see the debugging. So obviously in x, the value of x will be sorted based on x, and then it will be sorted descending order based on y. So also I need to check here, so I just need to modify the operator. So let's see. So we have them now. So I have it's sorted on x, and it's sorted descendingly on y. So y. So since x, it should work here. It's still not working, so I don't know. I'm using the comparison function. So if x is equal to x, if a dot b is equal to x, no, they are not equal. So the problem is here. I need to do that. So let's keep that as it was, and let's do the debugging. And now it's sorted. So whenever a is not equal to b of x, I will return b is greater than x. So a dot x is different than b dot x. So for example, so it's different. So I just need to, whenever I'm comparing the values, I will sort them b and then a. So a, it comes first because b is less, so it returns false. So this is how we can use the comparison tool in order to sort either on the first parameter, second, or third, or fourth. So we have also other way to do that. So just wait for a bit. So we have seen how we can do that. So once an array is sorted, we can then try to search for an element in this array. So in order to do that, I will reuse the same array. So I will remove all this. Maybe we'll use them later. So and we will write them again. So I have the array which contains those values, and then I need to sort them. So let's sort again the array. So it's called array plus 5. And then I need to look for a value in this array. So in order to find an element, we have the function called lower bound. So we know that, so we'll use binary search obviously, and we will look for that. So the function lower bound, it's here, it returns a pointer. So a pointer, it means I need to use a star. So int star position, it returns an iterator, a pointer over the elements if it's in the array, yes or no. So I'll be looking in array plus 5. So I'm looking in this array for the value which is equal, for example, 7. So if I find the element, I will print it. So let me show you if it's there or not. So %d dereference pose, because I need to display the value. And let's see the output. So and what it will be. So it's equal to 7. It means yes. So pose, it points to the element where it is. So it tells me yes, you have found the element. So I can also use the same concept. So I can use lower bound on a vector. So it's called v. So here I have v.begin. You know that v.begin, v.end, and I need to also look for the value 7. However, in order to do that, the return value is not a pointer because it's not an array, it's a vector, so it's an iterator. So in order to do that, I need to declare an iterator. So to declare that, I will use the notation vector. Obviously, our vector is of type int, and I need an iterator. So I will do it like this. And let's call it, for example, j. So j now is equal to the lower bound of the v.begin, v.end, and I can also display the same way. So however, here I have dereference j because it's also a pointer. So this is a bit cumbersome, so you can use this one if you are more convenient using static arrays. So we have an error. Obviously we are using a binary search on a vector that is not sorted, so we need to sort also the vector. Sort v.begin, v.end, and then we can call the lower bound function. So it's 7, so and this is good. So we can apply the lower bound. So we can see that we can look for an element like this. So what happens? So let's, for example, I'm looking for an element that is not in the array. So let's suppose I'm looking for 20. So let's see the output. So as you can see, I will have an error. So vector iterator not dereferenceable. So we know that there's some problem here. So even if also for the array, I can have a problem. So whenever we are doing binary search, so we will see how we can do this trick. So whenever we are calling for a position here, so let me just comment these because I will be working on those. So let me again just show you the output. So the output, obviously it's not equal to a number. So we know that the size is equal to 5, and I'm looking for an element 20 in this array. So it returns something else. So we know that array is equal to 5, so the elements are 0, 1, 2, 3, 4. So if the lower bound cannot be found, so it will return, so for maybe an array index plus 1 or a non-existent element for that. So in order to see how we can work with these, so what we will do that is we will calculate the difference between the pointers. So I will say that if position minus array is equal to 5, it means that I didn't find the element. So I will say that printf 20 not found. Otherwise, it means it was found, and I can print the value, for example. So let us check here. So 20 not found. So why we have that? Because let me print you the position, and let me print array. So those are pointers. It means the address of the value. So I have %d. The first one is array, and then I have position, and I will also display array plus 5. Just to tell you that position, it's the position after the last element. So this is why I'm doing the difference. If the difference equal to 5, it means that I have iterated over the five elements, and I have reached the end of the array. So the difference between the element that it comes after the last element and 5, so it will be equal to 5. So if I'm doing the difference between, so let's suppose I have an axis. So I'm trying to write, so I have an axis. So if I have here 0, 1, 2, 3, 4, 5. So if I have reached 6, so I can, and I have started from here, so the difference between this element and array, it would be equal to the size. So if I reach here, it means that the element was not found. So I'm printing here just to see the differences. So I will do the bar. So those the addresses. So if you can look well, I have 5503764. So this is the address of the first element, and then I have the address of the array plus 5. So it's the element that comes after the 5 elements, and then I have here the position. So the position is equal to the array plus 5. So the position is equal to the array plus 5. So it means that I didn't find the element. So the same applies for the function lower bound. So I can repeat the same stuff here. So let me do a sort. I have the pointer over the element. So obviously before doing that, before printing the element pointed by this iterator, I need to do also the same. So if, for example, j is equal to v.and, it means that I didn't find the element. So printf 20 was not found. Otherwise, I can have any other functions to, or as in printf, or I can deal with the value if it is found. So 20 not found. So this is the idea. So you should pay attention whenever you are dealing with lower bound. So the lower bound is associated with the binary search of function. So we have seen previously how we can deal with, for example, structs, as we have done here. So, however, in graph especially, we will not use too much struct. We will use the capabilities of C++. So we can make pairs, we can make triples. So in order to work with that, we have functions which called a pair that makes pair of values. So let's see how we can do that. So I have a pair, and let's call it here. So I will use the function, type def. It's not a function, it's a precompiler command. So I will use a pair. So pair, it takes two parts. So the first element is about an integer, and the second element I will also use a pair. So it's an element, it's a pair, it's two values. The first one is an integer, and the second one is about two strings. So in C++, we have the type a string, and I will call this element a state. So a state is composed of a pair, two parts. The first one is integer, and the second one is also a pair of strings. Now I can use variables of type state So for example, state A, I can make a pair. So this is all our predefined functions in C++. So the first one is an integer, and the second one also is a pair. So let's say I will use, for example, Anton, and I will make a pair. I don't know, I just having some names on my head. So I can have multiple pairs. Doesn't mean I can declare multiple variables. So let's say I have 4 variables. So I can also declare arrays of stuff like that. But let me do it like this. So I'll be using other values. So let's say here 7. So I will duplicate some of these values, and let's say 9. I will say here Zainab. So we have those type of state, and obviously, so what we will do that is that I will try to do the sorting of those stuff. So we will see that it's very easy to do the sorting on this type of type. So I have just state. However, I need, in order to call the function sort, I need a vector. So I will create a vector and add those states. So here I have a vector, but it's a vector of state. So it's very easy. I just need to place state in between those less and greater. And let's call it this vector test. So I need to add those values into test. So we know that we can use the function pushback. I will add A, and then B, and then C, and then D. And now I have a vector of 4 states. So a vector of 4 states. So CD. So now I have a vector, and now I can do, I can do the sorting. So this is very easy. So I will not print that because we know how to print all this stuff. I just, that using string I can use %s, and I can do the sorting. So let's do the sorting based on the first parameter. So I will do a sort test.begin, test.end. So obviously I need to write a function, I need to write the loop in order to print all these. So for I equal to 0, I less than 4, I plus plus. So I have here int I, and I need to print all these. So print f. Let's say, so I have value, it's %d, and then I have name1, name2, name1 equal %s, comma, name2 %s, \n. So the first one is test I dot. So what's the first one? So we don't know what's the first one because there's no name, there's no variable of this. So how we can do that? We have also, whenever we are using a pair, a constant called first. So we know that we are talking about the first parameter in the pair. And then I need to print test I dot second, because this is the second element in the pair. So whenever pair we have two, dot the first one. So it's dot second dot first. And then I have also the second dot second. So in order to do that, so obviously here we have string and strings, and whenever we are using a first and second with strings, so we'll see that we need to cast some stuff, but I will write this in order to see the errors, and then we will correct all these. So this is the printf. So I will try to debug this and see what we will have. So there's no output. So I have sorted, I have printed. However, at the end, there's nothing on the screen. So why? Because we have some problems in the output and the strings. So in order to overcome that, So let me write this. So we need to use the casting of a string. So in order to do that, I will cast first string. So this is string. And also, so we first convert it to a string. However, this is not enough because I have just said it's a string, but I need to convert it to a C string. So in order to do that, I need to call the function cstr. And the same would be applied for the second part. So I will recopy this because it's more easier, and then say that I will print the second one. So it's very conversive one. So let me just end all these and let's launch. So we have now desorting based on the first parameter. So I have 7, 7, 9, 10, and then we have the other values. However, we don't have any sorting based on the second one. So we have sorted based on the first value, but we didn't take into account the sorting on the other ones. So if you want to overcome this, we will see later how we can do that based on the first and second and stuff like that. So we can also add here some predefined functions. So if you already know that, or you write your own function in order to sort these values based on the elements. So as you can see, we know that whenever we are using a pair, so first it will be sorted on the value and then on the second parameter. However, the second parameter is a bit, it's also a pair. So it's sorted based on the first name. Okay, so there's no equal, and then it's not sorted on the second. So obviously, so if we have here Tito and Tito, it would be الصغير before Toto. So let's see if I place instead of Zainab Tito. So it will be, so Tito Tito. So we'll have both those first and then the second. So this is the idea in using pair. So it's first sorted based on the first element and then on the second, and so on. If you want to sort on the second and then on the first, so you need to write your own function. So this is the part concerning the vectors and the algorithm. So I will stop the recording now, and in the next one I will talk about the different data structures, the stack, queues, DEX, and priority queues, and we'll see how we'll implement them using C++. And thank you for watching, and see you on the next recording.